guys, so today you are going to be working on doing homework number 1 in the packet I gave you yesterday. So if you were not here yesterday, whoever your sub is, they have packets for you. Okay, so grab a packet from the sub, and then I'm going to do a few of these with you, and then I want you to finish yours, and then you're going to bring it back, and whoever your sub is, they can check it off with you and make sure that you have the answers correct, and then you will move on to doing your Alex assignment, which is also called the Pythagorean Theorem. So remember from yesterday, the Pythagorean Theorem is something that we can use to help us find missing side lengths of right triangles. So this theorem only works for right triangles, and it says a squared plus b squared equals c squared. And in order to use this to find missing side lengths, you have to remember that the side C is the one that is directly across from the right angle. So on question number 1, side C is going to be this side right here. This is side C. That's the hypotenuse. Side C is always the longest side. Okay, so on number 1, when it says which equation could be used to find the missing side length of the right triangle, well, you're going to have to say that this is side A, this is side B, and then this is side C. So we need to take side A, which is 12, and square that, add it to side B, which is 10, and square that, and that's going to be equal to side C squared. So the equation that fits that is this one right here. Okay, number 2. Which of the following statements is not a true statement? So be careful here. We're looking for the one that is not true. The legs of a right triangle are the sides adjacent to the right angle. So if I draw a right triangle here, and then this is my right angle, you can see that this side right here is right next to the right angle, and this side right here, sorry, this isn't drawing very straight today, is right next to the right angle. Those are adjacent to the right angle. Okay, so that one is true. So we're not going to pick this one because we're looking for the one that is not true. The hypotenuse is directly across from the right angle. Okay, so that one's also true, so we're not going to pick that. The Pythagorean theorem can only be used with right triangles. That one's also true, so we're not going to pick that one. The hypotenuse is always the shortest side length. This is the one that we're going to pick because that's not true. The hypotenuse is always the longest side length. Okay, so let's look at a couple of other questions together. Let's go ahead and do number 3. And it says, find the missing side length of each right triangle. So because these are all right triangles, we know that to find the missing side length, we can use the Pythagorean theorem. Okay, so the side directly across from the right angle, that is side C. So side A is 8, so we're going to say 8 squared. Side B is 15, so we're going to do 15 squared equals C squared. So 8 squared is 64. 15 squared is 225 equal to C squared. And so then when we add 64 and 225 together, we get 289 is equal to C squared. And then remember from yesterday, if you want to figure out what the C is, and the C has been squared, the way that you cancel out a squared is to square root. So to get rid of that squared, we're going to square root this side, which means that we also have to square root the other side. So C equals 17. So the missing side length for this one is 17 inches. Okay, now let's also go ahead and do number 6. Now the thing that you need to pay attention to on number 6 is this time we know the side length directly across from the right angle. We know side C. So we're going to say side C is 50. We can say side A we don't know, and then side B is 30. So when we write this out in the Pythagorean theorem, we're going to say a squared plus, instead of the b, we know that's 30, equal to c squared, which is 50. So now we have a squared plus 900 is equal to 50 squared, which is 2,500. And then when we subtract 900 from both sides, we're going to get a squared equals 1,600. And then to undo the squared, to cancel that out, we have to use the inverse operation of square rooting. So we're going to square root this side, we're going to square root this side. The square root of 1,600 is 40. So A equals 40 yards. Okay, that's the distance of side A. So you guys will go ahead and finish those in just a minute. I also want to do a couple of the word problems with you. So let's go ahead and do number 9. It says if the area of square 1 is 250 units squared. So that means when you do the length times the width of square 1, you're going to get 250. So I'm going to go ahead and put 250 in here because we know that's 250 square units. And the area of square 3 is 120. So when you do the length times width of square 3, you get 120. What is the area of square 2? So this is similar to what we did with the starburst activity. So basically to find the area of square 2, we're going to take the hypotenuse side, which that area is 250. We are then going to minus the 120, which leaves us with 130. 130, not a 230, okay? So 130 units squared. Okay, number 11. Will ran the diagonal distance across a square field measuring 40 yards on each side. James ran the diagonal distance across a rectangular field with a length of 25 yards and a width of 35 yards. Who ran a longer distance and how much longer did he run? So the question we're answering is who ran a longer distance and how much longer did he run? So let's go ahead and draw a picture for the distance that James ran. Oh, Will. Okay, Will ran across the diagonal of a 40 by 40 field. Okay, so that means he ran from here to here. And we need to find out the length of that diagonal. And then James ran across a rectangular field that was 25 by 35. And we want to know how far he ran. Okay, so these are just two, we end up having two different right triangles where we need to figure out side C. So for Will's run, we're going to do 40 squared plus 40 squared equals, we don't know this side right here. So this is equals and then C squared. So 40 times 40 is 1,600 plus 1,600 is 3,200 equal to C squared. And then if we take 3,200 and do the square root of that, I'm just grabbing my calculator, we end up getting an irrational number. So if we just round that to the hundredths, or yeah, let's round to the hundredth spot. So that's going to be 56.57. Okay, so this is for Will. That's how far he ran. Okay, now for James, we're going to do 25 squared plus 35 squared equals side C, which is the one that we don't know. So when we do 25 times 25, we get 625. And 35 times 35 is 1225. So when we combine those, we get 1850. So 1850 equals C squared. And to get rid of the squared so that it's just a c, we're going to do the square root of 1850, and we get 43.01. And that is for James. So now we can answer the question when it says, who ran a longer distance? Well, that's going to be Will. And then how much longer did he run? So if we take the 56, 57, and we minus the 4301, we get 13.56. 13.56, and we want to say yards. Okay, so you guys are going to finish this homework one. So you're going to finish, well, we did that one together, 1 and 2. So you're going to finish 3 through 8. You are going to do number 10, and then you're going to bring it back and have the sub check it off for you. They have the answer key. And then after that, you're going to work on the Alex assignment called the Pythagorean Theorem. And I will see you on Thursday.